Hello, everyone, and welcome to today's SANS webcast, 2020 SANS Enterprise Cloud Incident Response Survey Results, sponsored by Cisco, ExtraHop, Gigamon, Infoblox, and RSA. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speaker is Chris Dale, Certified SANS Instructor and Principal Consultant at River Security. If during the webcast you have any questions for our presenter, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Chris. And Chris, your webcam looks good.
Thank you very much. All right. So I like to have the web camera on so we can see each other, right? I see a small little black hole at the top of my monitor, but at least you can see what's coming out of that hole. So welcome to our webcast on results of our survey. So we did a survey earlier this year. I believe we concluded the survey around June-ish. And the survey basically concluded questions regarding, well, enterprise cloud incident response. How do we respond in the cloud? What type of impediments do we see? What type of challenges? What's our desired data? There's all kinds of threats in the cloud. There's all kinds of opportunities in the cloud. We have taken that data and, well, we've parsed it into a presentation and a white paper. White paper is linked to you in the chat. I believe I saw that just coming in, and also you will find links to it all across the webcast and so on. So nice little white paper out there for you to read as well. And this presentation is more or less, well, an iteration over the white paper and the data and the results that we have found. So my name is Chris Dale. I'm a certified SANS instructor, like Carol said. My background is development, so I see those urges, those needs into moving into the cloud environments. I've been doing IT operations, so I see it from the other side as well. Like, I see how hard these environments might be to contain and control and govern. And I've done security management. I've worked 3 years as a CISO, and for the past 5-6 years, I've been working as consultants doing just low-level penetration testing again. Yahoo! That's where I belong. I do quite a bit of incident response, and I do quite a bit of incident response in the cloud as well. So, I mean, that's why I'm sitting here speaking to you tonight. So welcome everybody. Let's get into our data and see what we have for you. First of all, the presentation's respondents. What kind of demographics are we looking at? Well, if we look at our respondents' demographics in terms of where they're from, we can see that we got respondents from all across Europe, Asia, America, and so on. We can see that headquarters are East Asia, Asia region there. We can see a ton of headquarters in America and South America. We have also customers representing. So basically, people are joining this survey from all across the world, and that is pretty good. In terms of which persons from organizations are responding to the survey, we are seeing that it's a lot of like technical people for the most part. I would assume they're technicals. People with the role of security administrator and security analyst role has been a dominating respondent, basically a dominant factor in who's been responding to the survey. We've had some security managers and directors as well, and I mean, they will probably help us get some better results in terms of seeing what goes on inside the full spectrum of our data sets here. Organizational size. Well, I'm pleased to say that we've got everything from small to the big ones. As you can see, these numbers here, we got about 40-ish respondents that are representing businesses more than 40 people. 40 people representing businesses more than 50,000 or large organizations. So that's pretty amazing that we got to get the big ones on board on this survey, and we got to see their input in how they use the cloud and how they respond to incidents. So you see that we got medium and large, we got about 20 people coming from that area. And when we get into the smaller organizations, we got the bulk of our respondents in those areas. Types of industries, you can see that many different industries are represented, all the way from banking and finance into government, and also cybersecurity and technology. Now, what is the cloud platforms that we've been quizzing on and what we've been asking respondents questions on? Well, platforms are different in their natures. Some cloud platforms will be providing Office support. So things like, for example, Google Apps, things like Office 365, they are fundamentally different than, say, Rackspace, say, Azure, say, Amazon, and so on. So when we look at the respondents, answer questions on which cloud platform does your organization use, not only is it multiple choice, it's also a different type of platform. Some are using, well, Office support platforms, and also some are using, well, more infrastructure as a service and for provisioning services. So you can see that we have actually multiple respondents that are using multiple cloud platforms. And that's not just like multiples, like I'm using Office 365 and Azure, but no, like more like I'm using Microsoft Azure and also Google Cloud Computing, or I'm using Google Cloud Computing alongside with Amazon. And that surprises me a little bit because, well, these cloud environments require training, they require knowledge, and like the more we chew over, well, we might have a potential problem here. So we'll zoom into that in a second. We also see like G Suite as the Google Apps, as I mentioned. We see IBM Cloud is represented here. And in the bulk of other, it was primarily DigitalOcean that people were using. So they're provisioning Droplets and other types of services in DigitalOcean, a competitor to the big ones soon. So interesting data sets that we have going on here. And can you imagine the different kinds of incidents that you might have across these services? So Office supporting cloud platforms, there will be completely different incidents than what we will have on, say, in Azure or Amazon. Completely different sets of types of challenges and problems that we want to solve in lights of visibility, in lights on governance, in lights of how we contain, eradicate, and remediate problems. So that's going to be interesting to look into and see if we can understand our data sets accordingly. Now, looking at the key impediments here, what does organizations believe are their key impediments in terms of achieving an effective incident response at your organization, okay? And well, the results, maybe not very surprising, but we see a shortage of staff and a lack of understanding of cloud capabilities as the key impediments. And we're going to zoom into these more soon. But if you consider this fact that we have shortage of staff and skills, and we have a lack of understanding of cloud capabilities, at the same time, we're using multiple vendors. This is a bit of a clash for me, at least like perhaps we need to maybe not diversify too much in our cloud platforms to enable us to build up that competency and build up those skills. We'll see. Lack of budgets for tools and technology is kind of interesting as well, because this could mean that our respondents are aware of the marketplaces and the vendors that provide everything from endpoint detection and response in the cloud into monitoring and network detection and response solutions, and all kinds of a plethora of different types of opportunities are present in the cloud. It's like the marketplace enables you to shop just the vendor that you want to try right there and right then, and pay as you go in many cases. So the lack for budget for tools and technology, 50% of our respondents said that this is their key impediment, is interesting. We can, of course, do more with products, with technology, with tools, but unless they receive the necessary care and love, a lot of the tools will perhaps, well, maybe they will create too much noise and make maybe life not necessarily easier. So we'll see though, but lack for budget and tools technology is interesting that we are seeing such a big gap there. And of course, I hope that organizations will address this issue by, well, funneling more money into cybersecurity and the cloud. Poorly defined processes and owners, and this is where I feel it kind of hits home in many cases as well. Look, who can provision stuff in the cloud? My customers, they tell me, well, our developers with direct access into cloud environments that can push a few buttons, and all of a sudden there's a patch, all of a sudden there's a release, all of a sudden there's a new container, etc., etc. Now, this scares traditional IT operations, this scares cybersecurity folks in general, because, well, how do we govern this? How do we control this? And ideally, we would have processes that will allow us to uh, control changes as we're moving forward. So we don't have all these unfederated changes across our environments. So we don't have the introduction of all this shadow IT that is possible now with the cloud. So available provisioning services and so on, so that we can basically help us understand which vulnerabilities are present and the actual risks they provide before we get hacked, for example, before we have incidents. I can feel this hitting home quite a bit to myself. Lack of integration with cloud security and engineering teams. So I can see this is also something that is going on in organizations. In fact, 35% is saying that this is a key impediment, that incident response teams don't integrate with our cloud security and engineering teams. Developers are doing A, they're building, engineers doing cyber, building, and incident happens, and all of a sudden it's up to the IR team to understand all of these pieces and moving puzzle pieces here and there, all of these components you've never heard of before. All of a sudden they're in your lap and you need to figure out what's going on. So perhaps we need to think differently regarding our integration with cloud security and engineering teams. What if we were thinking in terms of a more integrated way of dealing with cybersecurity incidents, so that the IR team will be an extension of these teams that already has the knowledge on how to operate out there? And then we have very interesting things such as inadequate visibility into encrypted traffic. Encrypted traffic, yeah. On a shared network stack in the cloud, it's not always easy to get a hold of. So you might need to offload SSL to some third party where you can do SSL inspection and decryption and so on. And I think this will then correlate back into lack of budgets and tools and technology. We will look into this further in terms of the encryption paradox here, where we'll talk about it soon, okay? But it seems to be a requirement for many incident responders that they want network data and they don't have it yet. We can correlate it up with budgets for tools and technology, I'm sure. What about lack of integration with our other security and monitoring tools? 22.6% is saying that we do not integrate properly with our existing security and monitoring tools. And that's, oof, we don't want to get to a point where we're blindly driving without having anything to clear the windshield and show us security information events. We want to have at least some insights into who makes changes, what type of changes are happening, so that we don't feel like, so that we don't have a big problem on our hands a year or two down the line when we discover that we've been compromised all along. So monitoring needs to be a priority, and luckily it's only 22.6% saying that this is a problem today. But honestly, let's not deploy new solutions unless there is some kind of understanding of the security information and events inside of that product that we can forward into some kind of monitoring. What I've seen from my customers and from this survey is that we might be approaching the cloud with a bit of too much of a traditional approach. Considering the shortage of staff and skill, we might be trying to solve something before we understand it. We're provisioning virtual machines and traditional components in the cloud environment, whereas we have all of these nice, up-to-date, modern approaches to a problem. We don't necessarily pounce on those solutions. Instead, we develop and use regular traditional approaches to IT operations. And this is typical of, we need to move into the cloud. We're going to go to the cloud and just make it happen. And we deploy a bunch of infrastructure as a service instead of serverless. We deploy a server instead of a platform as a service. We deploy a server instead of software as a service. Software as a service has tons of potential. It is lean, it is quite clean, it's still running off a server that is hosting your software as a service, but it's not familiar. And perhaps we avoid putting something on a software as a service model because it's not familiar anymore. And we are uncomfortable in putting something out there that we don't fully understand. Now, I will argue we don't fully understand infrastructure as a service either. Our servers are ridiculously complex, and I'm a bit of a fan of lessening the attack surface and so on. But in response to the shortage of staffing and skill, the truth is that for the future, I think that we need to do more with less. So we can't attribute, or we can't wait for more staff and skill necessarily. This is happening right now. We need to do more with less, and organizations can't grow linearly. You won't grow your capacities as incident responders, as cloud people, and so on. You won't grow those capacities at the same rate as you deploy solutions. So I think that we're going to see that shortage of staffing and skills, fine enough, but we need to deal with it. Doing more with less. Headcount does not necessarily grow proportionally with the number of services provisioned, okay? So this problem of us trying to seek more heads to solve problems is not always feasible for organizations. Luckily though, we are in a place where we can basically get answers to just about anything you can imagine within hours or days. We're living in the age of information, where you can go to Stack Overflow, you can go to YouTube on someone's tutorial, ask questions, and within, say, minutes or hours, you have someone replying to you. I've done this multiple times. 10 years ago, I was working on a project in Java Server Faces. Might have been more than 10 years actually, but a long time ago, I had a huge problem on my hands. I was developing proof of concept and I couldn't get rid of my problem. I went to Stack Overflow, and within hours, I had Balu-C, an industry titan, respond to me. Within 3 hours, I had a titan from the industry come take a look at my code and help me fix it. We are in a place today in 2020 where things are proof of conceptable. You can develop a proof of concept quite easy, and it doesn't hurt trying. It's not like you're investing upfront in a lot of hardware, in a lot of expensive tools and licensing and so on. You can today put up a service and see if you can make it work. And if you can't make it work, there are tons of resources out there, reliable resources, that will help you get this up and running. So maybe not just headcount, but maybe allow ourselves to experiment more for the future. Instead of deploying all of these infrastructure as a services, I'll get to that stats in a few minutes here, but instead of going the traditional route, why don't we experiment and see what we can do with the more fancy cloud deployments that are out there, the fancy capabilities that the cloud offers us. There's lots of fruits to be picked that are low-hanging that will give us a lot in return versus the traditional type of approach. If you look at the stats on what types of systems were involved in breach investigations, it is the traditional systems. You will see Amazon EC2, so infrastructure as a service, S3 buckets, so storage, your typical business email compromise, Office 365, so people's accounts compromised. Maybe we're seeing credential stuffing, password spraying. There's just been reports from Microsoft that they're seeing campaigns targeting users of Office 365 where they're slow and steady, casually spraying a couple of passwords an hour across the user base of organizations trying to break into people's emails. File sharing applications, nothing new and revolutionary here either. We're seeing that Google Drive, OneDrive, and Box and Dropbox and so on, they're getting compromised, and it's nothing new there. Databases, well, at least it's a platform as a service, but still, it's quite traditional, and Amazon other, sure, VMs are getting compromised. We're seeing Azure hosted databases getting compromised, and G Suite. I mean, there's a big gap. I think Office 365 is pretty much a leader in terms of Office support cloud type of deployments here. You see G Suite has 60.7% in terms of systems involved in breach investigations, whereas Office 365 is at a whopping 43.3%. Now, These systems are quite traditional. What if we went lower down into our data set here? We're seeing Lambda, serverless, and Azure functions at a meager 6.7%. Why is that, you might ask? Google's cloud computing systems are also not that often compromised here, but Kubernetes and things that are, well, basically functions that are not that traditional is getting hacked less. And there are multiple reasons for this, and we'll take a look at this more in depth. Traditional approach to the cloud, where we're talking about infrastructure as a service for the most part, and maybe some platforms, maybe some storage accounts here and there. These types of deployments typically have a large attack surface. There's multiple avenues for attackers to break that infrastructure by using existing TTPs, existing tactics, techniques, and procedures. There's existing tools and existing data on how to break into a VM, whether it's in the cloud or on-prem, it doesn't matter. And also, the traditional approach very often is open by default. Whereas if you look at more tailored approaches, for example, serverless and functions as a service, we're seeing that things are often contained by least amount of privileges. There's built-in segmentation of services. So unless you approve something, unless you allow something, then, well, unless you've done it and approved it, it won't happen. It's blocked by default. So kind of like safe by default. I'm not saying it is like that consistently across all cloud environments. I'm saying that a tailored approach, looking at, for example, functions as a service, serverless deployments, the attack surface is very, very small. Now, I had a case where we had a pen test and we breached a function as a service. We breached an Amazon Lambda function. We have what we would normally rate as a critical vulnerability. We have the ability to run our own functions inside of our clients' functions. Wow, amazing. But the functions are short-lived. They die almost immediately as I get access to them. There's nothing else I can pivot to. Credentials not existing in my case, in this case. And you might have metadata APIs. The clouds are actually getting rid of these metadata APIs that I could maybe leverage from within the function. I could reach into an API and pull out more information, potentially API keys and more. Those are disappearing as well. Serverless is more hardened by default. And when you're compromised, you just flick your finger and the problem is gone. The bad guy has to compromise you again, which is not a big deal, but you can just flip the light switch again, you turn that function on and off and redeploy all the time, making it very inconvenient to be a hacker. And that's a great idea. That is really, really nice. So a tailored approach, more daunting and requires you investing more understanding before you invest in something and before you go deploy something. But we want to be in a position where we seek to understand before we solve anyways. So I think this whole concept of looking at microservices and containers and so on, this is where IT operations needs to turn fast into, and it will enable us in incident response capabilities tremendously. A container, resetting a container with, if you have infrastructure as code, you can just snap your finger and you're rebuilding, deploying as many services as you would like. It is very convenient. Now, let's take a look at breakout times. So the time it takes from someone after they've compromised you to break out of that environment. So the breakout time. What can cloud providers do to reduce this metric? Because today, breakout times are in the minutes for some attackers. So the Russians were attributed with as low as 20 minutes from they have compromised your asset until they've done lateral movement and moved on into other assets. Perhaps using credential reuse, perhaps using finding vulnerabilities, low-hanging fruits, perhaps allowing it to spread other ways, but still we're in the minutes and hours for threat actors today versus, well, us having detection capabilities and containment, and that will take at least days, if not months in many cases. How can the cloud environment help us reduce or increase the time it takes for someone to break out? Cloud environments, think about the built-in resilience, where in many cases, you have default segmentation. It's not just any in the firewalls necessarily. You have to manually approve devices and add them to virtual networks and approve traffic and so on. And that makes it harder when we're considering that we are designing networks with the least amount of privileges from the get-go. Rather than everything is open, now let's close it down, we're instead opening it up. From an IT operations standpoint and cybersecurity standpoint, it's very interesting. This approach is very, it makes sense for us. For developers, it might feel a bit of like, it's a hassle because now we need to open and then we need to configure. But when everything happens as infrastructure as code anyways, when everything is defined in configuration files, you do this job once, you have self-documenting code, so your configuration of the environment documents how the environment is tailored, and all of a sudden you have something that might be bearable for the future, reducing breakout times substantially. All right, so we're going to do the questions at the end here. So any questions, put them out to Carol, and we'll put them and we'll try to address them at the end. All right. So breakout time seems to be less of a factor in today's cloud environments. It's harder for them. 42.7% answered that none of those incidents you responded to resulted in a cloud security breach. That's amazing. So you have compromised assets and they couldn't pivot. They couldn't escalate themselves into owning everything. And that is really good, because I think if you look and compare this to a traditional on-premise environment, you will see that traditional on-prem environments are soft and squishy, easy to hack. At least that's me and my team's experience when we're doing internal pen tests, for example. Tons of vulnerabilities, flat networks, everything is available. We might even see MPLS networks where allowing us to pivot around the world in a matter of seconds. Everything is open. And the cloud helps us address this, making it harder for the attackers to break out. So we still have unknowns here with a substantial amounts. Unknown whether any breaches occurred of 20.8%. That can be a good feeling, not having concluded that we're not fully breached. And then we see some statistics here where we have some incidents, in fact, several here, that did result in a cloud security breach, where the attackers were able to pivot something and well, basically get into more assets. So why do we think the cloud is not breached that often? Why do we think that the cloud is, well, the stats and respondents are telling us that, look, actually most of our incidents are not causing the cloud, the security of it, to be breached? Could be attackers' TTPs. Their tactics, techniques, and procedures are not focused on breaching the cloud yet. The attackers need to mature, and they're not maybe yet mature enough to realize that there's opportunities to be had. And I think these opportunities will be more and more realized as the security community is also starting to research this more and more, contributing with more information to the open source community, to our open world, giving out information about how to do lateral movement and pivoting. And let's just hope the defenders are able to take that information and limit and control their environments before attackers start to apply this as part of their TTPs. What about the defenders though? Could be that the defenders are not yet mature enough too. What if we fail? Like we saw on the previous slide, 20%. It's unknown whether any breaches occurred. What if we are failing to detect attackers are currently doing lateral movement and exploiting in our cloud environments, getting into the global admin accounts and so on? That's I'm a bit afraid to go into that area, because that will be very bad for us. What if someone gets global admin using techniques that are currently unknown to the rest of the world, and we know motivated attackers are banking on techniques. They're not sharing them with everybody, because the moment you start talking about it, we'll start to harden our environments. So there could today be potential in the cloud that allows attackers to persist in our cloud, potentially with administrative rights, and we don't know about it yet. So we as defenders might not be mature enough yet. Or maybe cloud services are just that good. The built-in resilience in terms of least amount of privileges, built-in segmentation, that good old IT operations type of stuff, where people are patching, your stacks are getting upgraded. Look, say a software as a service, considering how much do you need to consider patching for that software as a service? You can install WordPress as software as a service and continuously receive automatic updates to your WordPress. And you don't have to consider patching your Windows. You don't have to consider patching your network stack, your JavaScript, and all of that stuff, application servers. Those things are handled for us and potentially allowing us to dodge a lot of different incidents. But what is the future of the attackers, though, and their TTPs? We must expect attackers to mature because a full tenant cloud compromise is very interesting and very fruitful for attackers. I'm not talking about necessarily a full cloud compromise. That is rarely, we'll talk about it in a second, but a tenant compromise, meaning that you as a customer have your cloud breached. We must expect attackers to be motivated enough to try go for that. For example, targeting users with roles in the organization that can access the rest of the cloud environment. That would be very, very fruitful. That's one example attack path where we target developers trying to pivot with our compromise. We try to pivot into developer computers, into IT operations computers, and leverage all their API keys and accesses and sessions that are already reaching back into the cloud, providing services and accesses and so on. But there is many more avenues of attack in the cloud we as incident responders need to consider. So, for example, just recently, Mnemonic, a fellow Norwegian company, they released some research on dynamic groups in Azure. Dynamic groups could lead attackers into privilege escalation. And this is an example where we have our security industry talking about a new novel technique, and we can expect criminals and attackers now to change their TTPs and look for this in every cloud compromise that they perform. Such an attack against dynamic groups is quite simple, to be honest. You compromise some asset in the cloud, some virtual machine, and you enumerate the different, your online Active Directory, and you find that you have this membership of a group that is dynamic based on your UPN name. So your user principal name, your username, so to speak, is basically the deciding factor if you're a member of a group or not. And they found that such things are definitively possible using dynamic groups. And if you assign someone the VM contributor role, attackers can spread through the environment like wildfire with ease. In Azure, attackers with access to someone's account can invite guests into Azure. This guest that you invite can have this this dynamic string inside of the name. For example, here you see chris.dale admin role at gmail.com. I can register this email today, and if the admin role here is the deciding factor of me being a member of a group or not, well then, just like that, we have privilege escalation, and we can now spread into more workstations and other systems in Azure. We've also had real cloud escapes where we break the sandbox. So you're not just impacting your own tenants, but you're also impacting other tenants of the cloud. And this is something we don't expect to see very often, but it's definitively possible. This, in fact, is a shameless plug to a cloud escape that I did, where you was deploying some software as a service. Attackers find vulnerabilities in your software as a service. Then the attackers, basically, they now control your software as a service. They can run commands on it. They can do whatever they want. And from that system, from that software as a service, I was able to target the administrators themselves of Azure. So I'm able to break free from software as a service into the administrators of the Azure itself. Now, Microsoft patched this quite fast, but still, that is kind of frightening, considering our adversaries are earning billions, considering our adversaries are nation states, people with tremendous resources. I'm sure someone sitting on a escape like this for the future will be holding it very dear to themselves and not share it with anyone unless they lose their exploit. Are we able to discover impact? So when we're investigating these incidents, the questions were, and breaches, were you able to consistently and accurately discover impacted API keys, IAM roles, users, systems, data transactions, and threat actors involved? And good thing is, many incidents resolved that, well, they could actually discover consistently and accurately the users involved in breach. Well, that's great. Systems as well, and data, not so much. We're down in 40%, roles and API keys, transactions, threat actors, and so on. Systems have a lot of avenues for pivoting, potentially, especially when talking infrastructure as a service, and also potentially SaaS and PaaS as well. Users getting compromised, 74.4% accurately identified. Now, this could be a lot of business email compromise potentially, or it could be other things, but we must consider when users are involved, we must always consider the data the users hold. And I'll zoom into that on the next slide, but that's kind of interesting that we're seeing so many users being identified in this case. And data is only at 40.7%. Now, I connect those two directly. When I have a user compromised, I always want to identify what kind of data did that user have. Just consider someone's inbox, for example. So the fact that data is so low is a bit concerning to me. IAM roles, important to uncover, as many roles in our organizations and cloud environments will have privileges to cause effects in terms of pivoting. And in terms of API keys, it is very important to discover them being breached because, well, if an API key is breached, well, then we can now have data on the loose. These API keys can allow the attackers to go pull out more data from other applications and access, basically stealing more of our data. And that's what it's all about normally today in 2020. It's all about the data. Data is a new currency, we say. Now, threat actors, 22.1%. Now, this surprised me quite a bit, that we were able to discover that 22% of the incidents, we were able to discover the threat actor. So typically, an attribution is very hard, and very often we get it wrong. And sometimes it's just not worth our time and effort to look into threat actors. But perhaps the cloud does enable us to point fingers and get that visibility in terms of TTPs and understand who the attackers are, to the point where we can attribute a whopping almost 1/4 of all our incidents to which threat actor we have visiting us today. Very interesting stuff. All right. Now, breach components and impacted systems. So data, as I said, is the new currency. And when we look at what components were involved in these breaches, we see that data exfiltration, stealing sensitive data, is a huge component of incidents. I mean, that's what they're after. Unless they're after stealing, say, your Bitcoin wallets, or running ransomware, or running cryptocurrency miners, what would they otherwise be looking for? And this very typical data. The Thailand CERT has this beautiful threat actor encyclopedia where they map out a bunch of the different threat actors out there today, all the different APT groups and so on. And their primary motivation is information theft and espionage. So the numbers doesn't surprise me, but what we must consider in incident response is that, look, data has a lot of value, long-term and also short-term. What does your inbox contain? Which passwords does it contain? What sensitive strategy meetings, PowerPoints, spreadsheets, and so doesn't your inbox contain today? That can be applied and used on a short term. And long term, what about mergers and acquisitions? What about maybe your inbox has evidence of infidelity, for example? Where, for example, in Norway, we just had a major breach in the parliament where multiple politicians had their emails broken into. Contrary to them having multi-factor authentication, the attackers still got into their inboxes. And I'm concerned of the long term. If someone has some dirt on some politician today, that information might be used against them in, say, 2 years' time, in 3 years, in 4 years. So it can have untold consequences when data is breached. Same thing with sensitive trade secrets, intellectual property, etc. We have a hard time estimating or understanding the losses we actually occurred that day we got breached. That day we lost our data, we might think that we're okay, but a few months, maybe some years down the line, that data will be used against us. Someone is building our products with our schemas and our intellectual property without us knowing it, for example. Compromise of API keys, allowing attackers to change their scope and pivot into other types of services. Very typical that API keys are getting leaked today. API keys are often embedded in mobile applications. They're embedded in JavaScript left and right, here and there, allowing attackers to really easily just go into an application, find an API key, and start using it as their own. Now, I've seen that even though we lose API keys, the cloud does offer several, at least Google Cloud Computing and others, they do support you controlling your API keys. So you limit the attack surface they pose if they are stolen, and that's a good thing. We must also consider, in terms of data, which is the biggest bulk of these things, we must consider that there are regulatory and legal requirements in terms of disclosing when data has been stolen, if that data represents PII or healthcare. So personal identifiable data, we must consider, we must notify several government instances, for example. At least here in Norway, we need to do that. Healthcare data, you probably need to notify someone as well. So this has a significant impact, the data exploitation portion of our incidents. There's lots of things to consider. Now, let's take a look at timing. The stats from detection here. So if we look at this table here, we have compromise to detection, detection to containment, and containment to remediation, where detection is us figuring out that we were breached, and containment is us trying to block the attackers, limiting the damages, stopping the bleeding essentially, and remediation is us, well, discarding the attackers. We're now free. They don't have any more hold on us. So in cloud environments, the breakout time is already at a record low in normal environments, but what about the cloud environments, where we see that less than an hour time from compromise to detection is only at 3.8%, whereas most of incidents in the cloud that we talk about in this survey is taking us about 2 to 7 days to detect, and we have a whopping 15% at 1 to 3 months. This here is not ideal. What can an attacker do with your inbox in 1 to 3 months? What can an attacker use your API keys or your database or your public cloud services for in all of those months? We need to reduce this time substantially. And hopefully the cloud will enable us to get the necessary visibility and the necessary alerts that we can respond to and do perhaps automatic containment, automatic containment and remediation when we discover someone breaching us. So you can see that when we go from detection into containment, we're seeing that 30% of the incidents are contained after 1 to 5 hours, and less than an hour, almost 20%. I think this year is really good. I think this is different than what we see in on-prem environments, because the cloud enables us to redeploy quickly and limit the damages quickly. We have a lot of control in the cloud, and things are hardened, they're segmented, and we have redeploying capabilities, we have scaling capabilities, and infrastructure as code enable us to go down quite a bit in terms of time it takes us to contain the problem. If the attackers can pivot through all of our environments, it will take us a longer time to contain that problem. All right, and time for containment remediation is also quite fast, but not in every scenario. As you can see here, we do have 8 to 30 days down here, 2 to 7 days down here. So there's still a lot of improvements to be done in terms of timing and speed. And I think the cloud is a good enabler here. Security orchestration, automation, and response is going to support these numbers getting lower, and so we can get faster. So speed and agility, infrastructure as code, containment and remediation through just redeploying, for example, and then patching, beautiful. You can keep your service up and take it down for a second while you redeploy, and the attackers are gone. You can then get your stuff back on and start patching the problem. If the attackers return, you can redeploy again while you're patching and fixing up your services. So the cloud is good. It is a nice way for us to reduce these timings and allow us to have higher speed and be more agile. So consider agility. This is something that we need to focus on for the future. We need to follow in the footsteps of developers that are, well, always pouncing on new opportunities. We can't be slow in information security anymore because it's giving the attackers the upper hand. And cloud, it's new. Well, it's not new, but it enables new kinds of services that are limited and that are controlled and allows us to respond faster. What about third-party notifications? Now, this is pretty cool. What percentage of cloud incidents that you responded to were detected internally as opposed to being identified by an external party? So how many of your cloud incidents were detected internally as opposed to being identified by an external party? A lot of the incidents are actually determined by an external party. So why do you think this is? So many incidents are getting reported to you by a third party. I think it is the cloud providers themselves. We have this symbiosis with our provider here. We have our responsibilities and our concerns. We want to keep our products up and running. We don't want them to be compromised in terms of integrity and confidentiality. And what does the cloud provider think? Well, they don't want customers to lose faith in the cloud. They don't want customers to have problems that might impact other tenants. We see that this partnership with someone, it can be actually quite fruitful, where the cloud providers are telling their customers that, look, we see that you have problems. We see that you're currently facing, say, a distributed denial of service attack, and we have joint interests in helping you solve this problem. Keeping customers happy and also ensuring that every tenant is not impacted. Nice. Tools and capabilities, status quo at the moment. Now, we're not going to go through all of this. I suggest looking at the white paper to get more insights into this. But if you look at which tools and capabilities are highly integrated, we are seeing that SIM and endpoint detection and response is the primary or the highest rating, highly integrated tools and capabilities. We're also seeing that SSL TLS decryption with internal and data center traffic is very low integrated, okay? So network is not yet fully giving us insights into encrypted traffic. And we also see up here, network detection response capabilities is at 32.9%, giving us that nice visibility from a network perspective of scoping and so on, where the EDR capabilities typically gives us in incident response capabilities, it gives us insights into what actually happens on the host. Nice. If you look at the preferred cloud generated data, it's interesting because what our respondents said is that there is a strong desire for network related data. 38% is looking at, they want transaction data from encrypted network traffic. And this here is a bit of a paradox. There's a requirement for network taps and virtual network flows. And many of these are solvable, but it's kind of as a paradox because, well, the cloud wants to ensure end-to-end encryption. The cloud doesn't want to enable decryption necessarily because there might be other tenants' traffic on there. So decryption is not always desired, and yet we long for this data that we are so used to having in normal environments, in on-prem environments, and we lose it in the cloud in many cases. So that's a bit of a paradox. How can we deal with this? And it's just going to get harder for the future where, for example, TLS 1.3 has an encrypted SNI, so you can't see the name of the server that someone is pulling the certificates from anymore. And we lose even more visibility into that encrypted traffic. Out-of-band decryption is a possible and likely solution, and that's worth taking a look into. The current data aggregation platforms out there, we see a Splunk at a whopping 53.5% usage. That is amazing. And then we have Elk as a contender at 36.6%. Then we have different SIMs. We have IBM QRadar. We have the other at 18.3%, where we got things like Alien Vault XOR, Microsoft Sentinel, for example, Log Insight, Datadog, FireEye Helix, and so on. And we're basically seeing different vendors. Google's latest project, Chronicle, not the latest project, but one of the later projects from Google, Google Chronicle, is getting some traction at a 4.2% adoption rate in terms of data aggregation. Interesting. Maturity. So, how do you assess the effectiveness and maturity of your cloud IR processes? Sadly, we see a lot of the respondents say that we do not assess effectiveness or maturity of our cloud IR processes. So it's a foreign concept to many, 40%. Well, 24% are using well-defined public metrics, such as NIST, for example, to help track and evaluate and update this plan. Assessing the effectiveness and maturity of cloud, it can help companies better understand the platform they are operating in and helps maybe secure some governance on the services that we're deploying. So I think this is a good point to take into an account for our future, that we might need some plans to help us get governance and understand our maturity in the cloud. It might be a good project to go. Now, the thing is, in conclusions here, security, is it all about saying no? Is it all about going with the traditional approach, going with the familiar route? Security often says that you can't. And they want to seek to control the risk and they want to limit, but maybe we are doing ourselves a disfavor. When we're limiting and controlling too much here in the cloud, what are we doing really? We're going with the traditional infrastructure as a services instead of our serverless and function deployments, where basically we are in new age type of systems where we have less attack surface, less complexity, less avenues of attacks, but because it's so less familiar, we might decide not to go for it. And that is sad. Security teams often tell us that we can't. And I never want to be told that I can't, because I want to be told that I can if. So if we can change our mindsets as security people, we can perhaps seek to join the agile movement and take advantage of the cloud with all its innovation triggers, with all its potential. We can maybe do more with less. And that's what I hope that we can do. I think for us to survive and combat cybercrime and adversaries today as incident responders, we need to become much more agile. When I say patch in production, there shouldn't be chills going down your back. Patching in production is fine. Yeah, how many times a day, you might say? Availability, scaling, A/B testing, these are enablers that will allow us to do such things. Also, we might not be trained for the latest opportunities that the cloud offers. However, even though we're not trained, and even though we don't fully understand all of the components, the fruits might still be ripe to be picked. They might be ripe enough for be picked, and we need to consider, as security people, together with the organization, we need to ask ourselves, when do we declare ourselves ready for new technology? When do you go with a traditional approach versus a more safe approach versus a more interesting and new age type of approach, where we have more tailored services like service buses and queuing services and all of this stuff that we have in the cloud? I think that the cloud is a great enabler. It is greenfield. We get a chance to build new with fresh perspectives and lessons learned from our on-prem. We have abilities to be safe by default and carefully open up and make attackers do more work for less. Just consider a function. What happens when you breach a function? So there are multiple benefactors also in the cloud with similar goals, and all of this brings up a nice symposium of us working together to solve the same problems. And I think that is heading in the right direction. All right, so thank you very much for listening to me. I have some minutes to do Q&A, so we might have some questions coming in. Presentation will be public, by the way, and also the white paper is already public as far as I know, and I hope you will read it.
All right, thanks for that great presentation. We do have a question ready for the Q&A. However, if anyone has a question for Chris, please enter it into the questions window now. This question asks, might our attack could help to prevent new cloud TTP attacks?
One more time.
They say MITRE ATT&CK could help to prevent new cloud TTP attacks.
So if MITRE ATT&CK could be expanded into cloud as well, I'm very curious. Does MITRE ATT&CK already have something on the cloud? Because MITRE is currently, the attack matrix here is mostly on-prem stuff, right? But if we go to matrices, well, do they have one for the cloud? They do. And they do have for Amazon, GCP, Azure, Office 365, and so on. So what I love about MITRE is that it shows us a nice little kill chain and different techniques in each piece of the kill chain, allowing us to understand using the same language. We can talk about valid accounts as part of privilege escalation, for example. If we go into Azure here, for example, I'm a bit curious. Do they have dynamic groups yet in privilege escalation? No, they don't. But still, this project is lovely, and I really like how this gives us insights into attackers' TTPs so that we can better focus our defenses against what is currently in use out there. So we're not left in the dark, so we don't need to study, so we don't need to necessarily become a hacker to understand how to prevent people from, say, unsecure credentials, for example. So that's a great question. Thank you.
All right, that's all the questions I'm seeing. Chris, do you have any closing thoughts you'd like to share?
Other than go look at the white paper, it has the details, it has the meat. There's lots of interesting material that I didn't cover in this webcast. There's lots of things that you can look into yourselves, and you can come up with perhaps more insights than I was able to come up with. So I hope you get to do that, and thank you everybody for listening, and see you next time.
All right, thank you so much, Chris, for your great presentation, and to Cisco, ExtraHop, Gigamon, Infoblox, and RSA for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.